Okay, so let's cover open sentence. Have you heard of that term before? Open sentence? Ever in your life? Or is this the first time you're hearing it? You've heard it before. Okay, that's fine. You know, okay, if you've heard of it, that's fine. Well, an open sentence is nothing more but a mathematical statement, really. What is a mathematical statement? Well, here it is. That is a mathematical statement. Okay, so what is an open sentence? Well, it opens because it's not a complete sentence, is it? You still have to fill out what is that end to make a complete sentence, just like your English class, leaving out blank for you to fill in. In our math class, when I say an open sentence in math, that's what I'm talking about. What is n? What does n have to be to complete this mathematical statement?
2.
Okay, good. You know it's 2 because what plus 5 is 7. What if I don't give you the answer, but instead I'm giving you a whole set of numbers? This set is called what we call a replacement set. It's not yet your answer, but you know your answer is possibly in here. So for example, notice I'm using the curly brace. It's just a way that we signify a set of numbers. So for example, I have 0, 1, 2, 3, 4, 5, 6. This is called a replacement set. Okay? I know that you just probably look at this and you figure out, okay, I know what my answer is already. However, just pretend you don't know. You don't have a clue. All that you're doing right now is plugging in. This is why we call it a replacement set. You take each value inside the set and replace the n with it. And test it out to see which one will make this open sentence true. Okay, so let's test it. Let's do a table test. So this is the value of n that I want you to test. Okay? Whoa. Oh well. Oh, there we go. That doesn't let me do it. That's fine. Alright, so I want you to plug into n plus 5, right? And you want to see if it's going to give you 7 or not. Because you want to see if it's going to give you 7. So let's check. Let's say n is 0. 0 plus 5. Will that give you 7? No. So let's try 1. 1 plus 5. Will that give you 7? No. 2. 2 plus 5. Will that give you 7? Yes. Let's check. So you know that that is your answer and nothing else. Why is it that we only have one answer for this one, but not multiple answers?
Because all the numbers are different.
Yeah, all the answers are different. This is an equation. Equation means the left-hand side has to equal to the right-hand side, and you know that for it to equal to the right-hand side, there's only one value that will make it work at this point in our time, right? At this point in time. So that is our solution. Is that correct? So we take that and we put it into another set. Notice every time I say a set of numbers, I have to use that curly brace. Okay? And that is our answer. We put it into our set, and we call this a solution set. That's it. Question on that. On what is an open sentence, what a replacement set is, and what a solution set is. Yes, go ahead, ask.
So, are we just going to answer questions like these, like about sense, we'll just do that brace?
Basically, yeah. If I'm asking you for a set of numbers, you have to enclose your number inside the curly braces. Yes.
Why is the answer called a solution set if it's not a set?
Like I said, you understand why. Oh, what do you mean? It is inside a set.
Oh.
Your solution is in, look. At this point, you only see one solution, right? And when I say a set, you expect more than one, is that what you're saying? You will see why in a minute, okay? But for now, it's just the way that we write a set. Yes?
Is it because when there's two variables,
That could be true, but we'll talk about that case in a minute. But are we clear on what an open sentence is, a replacement set versus a solution set?
Yeah.
Okay, good. Yes?
Is it called solution set because it was part of the set in the first place?
No, it's called, okay, fine, yes. A solution set is actually the set that will make the open sentence true. Notice that nothing else can be included in a solution set unless you can verify that when you take that number inside the solution set and plug it back into my open sentence, that will make it true. You see it? And that's the only one that will make it true. Okay, all right. So let's check this next one out. Pretend I have something like this. Let's see, what should I have here? There you go. Let's say half this. Is that an open sentence? Yes, it is, because I don't know what x is. Okay? So let me give you a replacement set for that you can test. This is already given to you, by the way. If I give you a problem, I will give you the replacement set and you have to test it. How do we test it? I just want you to put it back in the table form to organize it. It doesn't mean it's absolutely necessary to do it, but it's just our way of organizing our data, okay? So for example, here's my replacement set. I want you to go ahead and test. Let's see. -2, -3, -4, -5, -6. Let's say that. Okay? And we need to test to see which one will make it work. So let's test. I want to test x equal to -2, right? I want to plug it in here. Is that true? My question, will that make it equal to -8? So let's test it. -2 and 2x, which will make it 3 times -2? Plus 7, will that give you -8? -6 plus 7 is +1. It won't equal, right? So this is not it. Let's jump for a little bit here. I know we test -3, -4. What should we test next? -5? Okay, let's test -5. 3 times -5 plus 7. -5 times 3 is? 15. -15 plus 7 is -8. Yes. So because of that, we know that -5 actually works. And you know there's only one number that will make it work, right? Because of that, we pull it outside of the replacement set and we put it inside the, what is this set called? Solution set. Any questions on that one? Am I making myself clear on what an open sentence is? What a replacement is? What is a solution set is? Okay, last example here. It's actually pretty straightforward. Let's take a look at this. So pretend I have the following. What is that? Someone read that out loud for me? Yes, go ahead. Okay, can you say it? Yeah.
X divided by 2 is greater than or equal to 12.
Yeah, greater than or equal to 12. Okay. Is there any confusion here on when to call something greater than and when to call something less than? Remember our general rule here is that the mouth number that you learned before, if the mouth is facing a certain number, then that number is the bigger number, right? So if you kind of draw yourself, it'll probably look something like this. You know, there it is. And since it's eating, or it's facing x over 2, that means this side is bigger than the other side. If this is bigger, then it's greater, right? Then that's why you say x divided by 2 is greater than 12. But in this case, we have the bar below. It will become greater than or equal. Okay? So this is what we have. Now my next step is, I'll give you a replacement set, and you figure out which one will make it work. Okay? Here we go. Let's see. 15, 18, 20, 24, 26, 28. Okay, so I just give you a replacement set, and I want you to test out to see which one will make the above inequality. Notice I'm saying inequality this time because it's not an equal sign, right? Which one here will make the inequality become true? So let's test. Will 15 work?
No.
If you take 15 divided by 2, what do you have? 7.5. So you're basically saying, if I take 15 and plug it into x divided by 2, it's only 7.5. Will 7.5 be greater than or equal to 12? Is that a true or false? It's false. And you move on. So if I take 18 now and divide it by 2, well that, it's only what? 9, right? Is 9 equals to or greater than 12?
No.
That's not it either. So you know that I can't use that, I cannot use that. Let's check 20. 20 divided by 2?
No.
Still too small. What about 24?
Yes.
24 divided by 2 is 12. Even though it's not greater than, it is equal. Because of this condition, so you know 24 works just fine, right?
Yes.
Right? What about 26?
Yeah. Yes.
But notice, is that okay? Because
It's great.
as long as it's greater than it's fine, right? So that worked just fine too. What about 28?
Yeah.
Sure, it's bigger. So notice that this time we only have one answer, we have 3. Because look at our condition. As long as the left-hand side is bigger than 12, we're good to go. No, this is why we call it inequality instead of equations, right? An equation is one solution. For inequality, you expect to have multiple solutions, right? Because if I say, hey, give me a number that's bigger than 5, can you just give me infinitely many numbers? Right? You can say 5,000, 5 trillion, right? That's what I'm saying. When I'm using inequality, I expect to have multiple answers. So now that we have our answers, we put into what set? A solution set. So here we go. I'm going to put 24, 26, and 28, and then I close that brace, an early brace, and I have myself a solution set.
Oh, that's why it's called a solution set, because it could be more than one.
It could be more than one, right? Okay. Any questions so far on what we're doing today?
That's pretty easy.
Okay, we're done then.